Hello my dear friends, I am Shubham from LearnoHub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So friends, as you all know, we are studying your class 10th ICSE chemistry and so far we have completed 3 chapters. Now, in this video, we are going to start studying the 4th chapter, which is Analytical Chemistry, and in this video, we are going to see the topic of this chapter, action of NaOH on metallic salt solutions. Okay, so without wasting much time, let's start and let's rock. So friends, as usual, starting with the first question, and that is why we have to study this particular chapter. So you would say, sir, every time you come up with this question, and just like it's very simple, we just study these chapters because they are in our syllabus. If we don't study, we would lose marks and all those things, right? But apart from that, there should be some reason, right, when you are studying anything, because out of the box when we are thinking, okay, out of the box when we are thinking for something else rather than the marks, so we should actually have some knowledge with us, correct? So then why we are going to study this analytical chemistry? So let's try to figure out why is it really important. Now, just first let's try to get a crisp idea of what actually analytical chemistry is. You may have heard it for first time. So this is a branch of chemistry, just like other branches like physical chemistry, inorganic chemistry, organic chemistry, and this branch is also quite a vast branch, okay, very vast, very diverse. But for now, don't worry, we are just going to see its 2 aspects, very simple aspects, okay. First is qualitative analysis and the second aspect is quantitative analysis. Now, how to get hold of these 2 terms, okay, what are actually they? So you can see on the screen, I have come now with pasta, okay. So if suppose I'm now figuring out that I have to make this, I have to eat because I'm hungry, but before that, suppose a question arises in my mind that whether this pasta is safe to eat, okay, whether there are any harmful substances present in it or not. So suppose I would take an example of lead. So if this lead is present in this pasta or not, okay. Now if I want to find the answer to this question, if lead is present in this pasta or not, so that means I'm trying to find out a particular component in this substance, okay. And what I'm doing is I'm actually analyzing, okay, the presence of that component in this substance, okay. So such type of analysis, okay, where we are checking actually the quality, okay. See, quality, I'm checking the presence of a particular component in that substance, and that component may be harmful, okay, or may not be harmful. So such type of analysis is qualitative analysis, okay. Now suppose I didn't found lead, so it's well and good, I will quickly make pasta and I will eat, but I found lead, okay, fine. But then just I want to make one thing, I should be sure of one thing, that lead which is present in this pasta, it should not be above that permissible limit, okay. It should not be so high that it would harm me. If it is very less, if it is very in minute quantities, then that's fine, okay, then that's fine with this pasta. So then what I need to actually find out, the second question is how much lead is present, okay, the quantity of lead, right? And this is what we call as quantitative analysis. Here we are finding out the quantity of lead which is present in this pasta, okay. So finding the quantity of a particular component in that substance, okay, analyzing the quantity of that particular component in the substance, okay. So it is called as quantitative analysis. Very simple. Now let's get back to this pasta. So like this pasta, you also eat every day the foodstuffs which are packed, and you know most of these foodstuffs are rigorously tested, okay, rigorously analyzed. They are passed through this qualitative and quantitative analysis thoroughly, okay, so that they may not end up delivering us the foodstuffs which are harmful, and in turn we may not end up eating those foodstuffs and fall ill. Okay, so can you realize the importance of this analysis, this qualitative and quantitative analysis, right? Because if we miss this step, then we would be in a great trouble, right? We would eat something which would be harmful for us and we would fall ill. So I hope now you would have understood the importance of this analysis part, right? So now I think if you have realized the importance, then you would be feeling somehow in your from your inner self that I need to study this, right? So then let's start. Okay, now what actually we are going to learn in this chapter? Okay, so what we are actually going to do is we are going to do qualitative analysis. Okay, now for that, suppose like you are in lab, I am in lab. Okay, from now onwards, whatever we are going to study, okay, you have to think that you are also in a chemical lab, I am also in a chemistry lab. Okay, and now we are going to study the reactions. Okay, and we are going to study how we are going to do the qualitative analysis. Now how means which qualitative analysis we are going to do, what we are actually going to find. Okay, so qualitative analysis, we know to analyze the presence of a particular component, okay, in a substance. So in this chapter, what we are going to do, we are going to analyze, or we are going to find out, okay, which metal ion is present in metallic salt solutions, okay, which we are having. So we are having in this chapter, okay, we are going to have 6 metallic salt solutions, okay, like this. I'm having it in the test tubes, okay, 1 2 3 4 5 6 in this way. Okay, and in this test tubes which I am having the metallic salt solutions, we are going to find out in which test tube, okay, which metal ion is present, okay, or in which metallic salt solution which metal ion is present. Okay, so it's interesting, right? Now let's get back to this metallic salt solution part, because we need to understand the context very much thoroughly, okay, in order to make the concept very much clear in our mind. So metallic salt, let's first break it in metallic salt and in solution. 2 words. Metallic salt simply means any salt which is having a metal ion. Okay, so suppose I am taking NaCl, so this salt is having metal ion Na plus, or I am taking Na2SO4 sodium sulfate salt, okay, it is having Na plus metal ion. So these are metallic salts. Now coming back to the solution word, so what actually this solution means? Okay, here we are dealing with the aqueous solutions. Aqueous means here the water is one of the component of the solution, which means when we are making a solution, we are using water, okay, as one thing, and then we are adding the metallic salt into the water. Okay, so I am having the water, I am adding this metallic salt in the water, and a solution is formed. Okay, but what actually solution is? Solution is simply a homogeneous mixture. Okay, homogeneous mixture. Okay, not that genius, it's homogeneous mixture. Okay, now this solution is a homogeneous mixture of, we can say, 2 or more components. So you have 2 or more components, you mix them, but then the question arises that what actually this homogeneous means, right? So homogeneous means the composition of the mixture or the properties of this mixture, okay, are uniform throughout the mixture. Now let's understand this thing. Okay, it's quite simple. Suppose I'm having a metallic salt, okay, and I'm adding it into the water, but this metallic salt, it after adding into the water, it forms a layer at the bottom. Okay, it doesn't get mixed with water at all, it just settles down at the bottom, and I'm clearly able to see the metallic salt at the bottom of the beaker. Okay, suppose this is a beaker, water, and I'm clearly able to see the metallic salt at the bottom of the beaker. So here we have added water, we have added the metallic salt, we have tried to mix the 2 components, but this mixture is not homogeneous. Why? Because the composition, here see, the word composition means in this upper part of this mixture I can find water molecules, in extreme lower part I can find the salt particles, correct? But this is not uniform, right? If I would find, okay, some components, okay, which are uniformly present, means which are present in each and every corner of the solution, okay, the same component is present. Here I am finding water molecules in the upper part, the salt particles in the lower part. That's not uniform, right? So now what is actually the uniform composition then? So I am adding now a metallic salt which is soluble in water. Okay, now what would happen? We know soluble in water means when I am adding this metallic salt, suppose I am adding NaCl, okay, and I know this metallic salt is soluble in water. So what would happen? We have learnt it. This salt would break up into Na plus ions and Cl minus ions, right? And these Na plus ions and Cl minus ions are like dancing here and there in the solution, and they are thoroughly, means they are throughout the mixture, they are uniformly present. If you would take this part of mixture, you would find Na plus ions and Cl minus ions. If you would take this part of mixture, you would find Na plus ions, Cl minus ions, water molecules as well. Same way, okay, here also water molecules are present. Here also Na plus ions, Cl minus ions, water molecules are present. So the composition is uniform. Wherever you go, that part of mixture is having same particles. Okay, now this is the meaning of uniform composition throughout the mixture. Properties, don't worry about it. We have to just consider here about the composition only in order to understand what is homogeneous. Properties means all the properties, once the composition becomes uniform, the properties also become uniform. Okay, so such type of mixture is a solution, and in order to form the solution, okay, what we needed is, we needed a metallic salt which is soluble in water, right? That's the point I want you to get into your head right now, okay, because throughout the chapter, okay, the first part of the chapter, we are going to deal with the metallic salt solutions only. Okay, now before moving ahead, okay, in this lab, okay, now we are going to start doing reactions. But before doing that thing, in first place, just now we saw that we need metallic salts which are soluble in water. So now let's see which salts are actually soluble in water. This would help us a lot when we are writing the chemical reactions. Believe me, it would help you a lot. Okay, you won't feel confused. Whatever question may be asked to you, you can just answer it very easily if you are thorough with this concept of solubility of salts in water. Okay, you have to just remember this 4 points and that's it. Okay, so first is all the salts of ammonium, sodium and potassium are soluble in water. Okay, for example, suppose I am taking ammonium nitrate or ammonium nitrite or ammonium chloride, ammonium bromide, ammonium iodide, ammonium sulfates, ammonium carbonate, ammonium sulfide, ammonium sulfites, ammonium phosphates. Any ammonium salt I am taking, it is soluble in water. Understood? Same goes with sodium and potassium. Any salt of sodium and potassium, it is soluble in water. Keep it in your mind, fixed this thing. Very clear? Now moving ahead, all nitrates and nitrites are also soluble. So now if you would take calcium nitrate, calcium nitrite, zinc nitrate, zinc nitrite, okay, lead nitrate, lead nitrite. So now the metallic ion, whatever metallic ion you wish you take, and that nitrates and that nitrites would be soluble in water. Okay, so this is the second thing. Second point you have to remember. Third one is all chlorides, bromides, iodides are soluble. Now this, what does this mean? Chlorides, bromides, iodides, same like nitrates and nitrates. You take calcium chloride, you take lead chloride, no, not lead chloride, you take calcium chloride, you take zinc chloride, you take ammonium chloride, you take sodium chloride, potassium chloride, or in the same case like bromides, okay, you take potassium bromide, sodium bromide, zinc bromide, okay, lead bromide. Now why I said lead chloride, we will just discover it in few seconds, but just like chlorides, you take any other bromide salt, okay, just by replacing the metallic ions, okay, sodium bromide, potassium bromide and all those things, calcium bromide, zinc bromide. And same case with the iodides, you take sodium iodide, potassium iodide, zinc iodide or calcium iodide, okay, all these chlorides, bromides and iodides would be soluble, okay, but here comes the exception, and you have to remember just these 3 salts, okay, because the chloride of mercury, okay, Hg2Cl2, you know Hg is the symbol of mercury. So chloride of this mercury, Hg2Cl2, chloride of silver, AgCl, and chloride of lead, PbCl2. These three chlorides are insoluble in water. Okay, and one more interesting thing about this lead chloride is, okay, only this lead chloride, it is soluble in hot water. Okay, so this means that it is insoluble in cold water, but it is soluble in hot water. Okay, rest two are like insoluble in water, hot, cold, doesn't matter. Okay, so this is the third point. Now the fourth one and the fifth one. So fourth one is also very simple. All sulfates are soluble. Okay, all sulfates are soluble, but just there comes three exceptions again. Okay, these three exceptions won't change. Here also three exceptions. You just remember as three idiots. Okay, then here again three idiots have came, but now here the calcium sulfate, lead sulfate, and barium sulfate. These three sulfates are insoluble. Okay, apart from these three sulfates, all the sulfates are soluble. Fourth point. And the last one, very simple. Carbonates, all sulfides, all sulfides, all phosphates. Okay. Now I think I don't need to no need to explain you what are carbonates, sulfides, and sulfides. We have seen in the previous chapter, right? So you take any metallic ion along with carbonate, that becomes metallic carbonate, metallic sulfide, okay, and metallic phosphate. Okay, so all these salts are insoluble. Okay, they are insoluble. Here we were talking about soluble, and then there were exceptions. Now the last point is like thoda hatke, okay, tricky. All these are insoluble, and the exceptions are carbonates, sulfides, phosphates of ammonium, sodium, and potassium. These are only soluble. Okay, very simple. Understood? Now again, coming back to the same interesting thing which we are going to do now in this chapter, right? What we are going to do, we are going to find out the metal ion, okay, which metal ion is present in which metallic salt solution. Okay, now let's move on to the main crux. So I have told you we are having 6 metallic salt solutions with us. Okay, they are in the 6 test tubes. Okay, don't worry about the shape of the test tubes. Okay, don't pay attention on the shapes. They may not be the perfect one, but what we have to just figure it about how we are going to find the metallic ion, which metallic ion is present in which metallic salt solution. Okay, so we are having these 6 metallic salt solutions, and these 6 metallic salt solutions, we know that, okay, one is calcium salt solution, one is zinc salt solution. Okay, out of the 6, one is lead salt solution, one is copper salt solution, okay, and the remaining 2 are iron salt solutions. Okay, now you would say, sir, how 2 iron salt solutions? I will tell you, just wait. Okay, now this 6 salt solutions, now this calcium salt solution which I am talking about, in this calcium salt, our calcium is in Ca2 plus ion. Okay, so calcium is as Ca2 plus ion. Same way in zinc salt, our zinc is Zn2 plus ion. Okay, suppose I am taking an example, suppose calcium nitrate. Okay, this calcium salt which I am taking example as calcium nitrate. Now see, in this calcium nitrate, this is the formula. Now we know this calcium is in Ca2 plus ion, nitrate NO3 minus. Okay, so we need 2 nitrate ions in order to balance the charges, 2 plus 2 minus, and then they combine and they form calcium nitrate. So since 1 calcium, 2 nitrates, so see, we made a formula. Okay, we put that NO3 entirely into the brackets, and then we put the 2 in the subscript. Okay, so we are having the calcium salt solution, and that calcium salt solution, okay, is made up of a calcium salt, okay, which is having Ca2 plus ion. Same way zinc salt, okay, a particular metallic salt solution, out of the 6, a particular metallic salt solution is made up of zinc salt, and that zinc salt is having Zn2 plus ion. Same way lead salt is having Pb2 plus ion. copper salt is having, sorry, Cu2 plus ion, okay, and one of the iron salt is having Fe2 plus ion, and one of the iron salt, another iron salt is having Fe3 plus ion, okay. So what we call to this Fe2 plus, just you remember it here itself, it would be easier for you, ferrous and ferric, and I know that most of you would have, means most of you know that we call Fe2 plus ion as ferrous ion, Fe3 plus ion as ferric ion, okay. Now moving ahead into the story, what all things we know, I'm just trying to tell you, okay, before starting to find the metal ion which is present in the particular metallic salt solution. Now what one more thing we have to study is this salts colors we have to study, okay. So I'm just making here the column, okay, color of salt, okay. So now a very simple trick you have to remember in order to remember the colors, okay, that is, if the particular salt, okay, is made up of a element, okay, which is a representative element. Now you need to get back to that first chapter which you have learned, okay, or else you can just go back to your 9th grade as well, where you have studied about the periodic table. What are representative elements? These are the elements of group 1, 2 and from 13 to 17, okay, these are the representative elements. So any element among this, okay, and the salt is made up of that element, okay, so that particular salt would be generally colorless, okay, very interesting. And if the salt is made up of a transition element, now again you have to move back to the periodic table, okay, no worries if you don't remember it, okay, you should actually remember it, but no worries if you don't get the click of what are the transition elements. Very quickly I'm going to tell you, transition elements are those from group 3 to group 12, okay, these elements which are present in group 3, from group 3 to group 12, okay, all these elements are transition elements. So if the particular salt is made up of a transition element, then generally those salts are colored, okay. Now we have to just apply this logic here. So we know calcium, okay, so calcium is a representative element, okay, so salt of a representative element, so it is colorless, very simple, I'm writing here colorless, okay. So this Ca2 plus salt, okay, the calcium salt which is having Ca2 plus ion is colorless. Now moving ahead to, not to zinc, let's move to the lead, okay. So lead also is between group 13 to group 17, okay, it is a p block element. So this lead also a representative element, so again it is also colorless, okay, I am writing a dash in front of it so that it would be easy for you, okay. Then copper, now let's come to the transition element. See, copper is a transition element, okay, iron is a transition element, okay. Now these elements salts would be colored, okay. So this copper salt, okay, which is having Cu2 plus ion in it, it is blue colored, okay, it is blue colored, okay. Now same way the iron salt, okay, which we are having, and that iron salt is having Fe2 plus ion, okay, Fe2 plus ion, ion. So this iron salt which is having Fe2 plus ion, it is having light green color, okay, so light green, very clear. And this iron salt, the last one, which is having the Fe3 plus ion, this salt is having yellowish brown color, okay, yellowish brown. Now coming back to this zinc, okay, now zinc is actually, you would find it in the group 12, but it is not a transition element. You would study in your higher classes why it is not a transition element, no need to worry about that right now. So since it is not a transition element, the salt of zinc is not colored, okay, so it is having a colorless salt, okay. So now you have learned, okay, the colors of the salt. So this was the first thing which we have to learn, okay, before starting to do the reactions. Actually, now the same way we are going to see the color of the salts when we are adding it into the water, it would form a salt solution. So now we are going to see the color of the salt solutions. Okay, color of this salt solutions. Okay, so color of this salt solutions. Okay, so I am adding this calcium salt having Ca2 plus ion in water, and now what is the color? Same, colorless. Okay, same way when I am adding this zinc salt having Zn2 plus ion, okay, into water, what would be the color of the solution? Same, colorless. Okay, same is the case with the lead as well. Okay, the color of the lead salt solution is also the same. Now in case of copper salt, when we are adding this copper salt having Cu2 plus ion in water, we get blue colored solution. Okay, so blue colored, same as that of the color of the salt. And moving ahead, in case of iron salt having Fe2 plus ion, okay, when we are adding such iron salt in water, we are getting again the same light green color, okay, or pale green color. So light green color or pale green color. Okay, and in case of the iron salt which is having Fe3 plus ion, when we are adding it into the water, okay, we get yellowish color, yellowish. Okay, I am deliberately writing the colors of the salt with the same color so that it would be easy for you to remember. Okay, okay, so what we have seen, the color of the salt and the color of the salt solution, and you have to remember it. Okay, it would be actually, you would actually remember it while we are learning the reactions as well. Okay, when we are doing the reactions actually, okay, now we are going to do the reactions actually, so at the time you would actually get to remember them. Okay, you would remember them easily. Now let's move to the actual main question. Now you would be curious to know, sir, just tell us that how we are going to identify the particular metallic ion, okay, in that particular metallic salt solution. So in this problem, who is going to help us? Okay, the alkalis, right? The alkalis are going to help us. And now we are going to take help of sodium hydroxide first, okay, and then with the help of sodium hydroxide we are going to identify which metal ion is present in the particular metallic salt solution, okay, and also then we are going to take help of ammonium hydroxide as well. Okay, so sodium hydroxide will also help us, and we are having another option as well. Ammonium hydroxide also helps us to identify which metal ion is present in that particular metallic salt solution. Okay, so what we are going to simply do is we are going to add sodium hydroxide first. We are going to add sodium hydroxide into this, what we are having, this 6 metallic salt solutions, right? One by one we are going to add, okay, slowly, drop by drop, and then we are going to add it in excess, means directly we are going to add so much amount, okay, of it. Then we are going to do the same process with the ammonium hydroxide. First we are going to add drop by drop of ammonium hydroxide, okay, and then we are going to add excess of ammonium hydroxide. Okay, so now first let's do this part. Okay, first let's see what is the actually action of sodium hydroxide, okay, on this metallic salt solutions. Now comes the interesting part. Okay, now let's start figuring out that which metal ion is present in which of these metallic salt solutions. Okay, we are going to take each metallic salt solution and then we are going to figure out which metallic salt is present, which metallic ion is present in that particular metallic salt solution. Okay, now let's start. But before that, I would recommend you take a big A4 size paper, or like bigger than A4 size paper if you have, and we are going to now write the reactions as well, and I'm going to try and make this thing very interesting and colorful as well. So you can also have this green, yellow and blue color markers like sketch pens and all those things. You can have some colored sketch pens with you so that when and where needed you can use them. Okay, and make sure you are using a big paper, because we are going to now see 6-7 reactions, okay, in a row, because we are having 6 solutions, so 6 reactions. Now see, now I am going to start with the colorless solutions. Okay, let's not move into the colored one. First let's start with the colorless one. Okay, let's keep the enjoyment at the last. Okay, it would be easy, much interesting. So first colorless solution I am going to take. Okay, and now let's start that which metal ion is present in this particular colorless metallic salt solution. So we know now we are going to start with the NaOH. Okay, with the help of NaOH first we are going to see. So that's why it's written as, the topic is action of NaOH on certain metallic salt solutions. Okay, Now start to pay attention from this topic onwards. Keep your ears open because this is the favorite topic of the people who set your paper. Most frequently the questions are asked from this topic. Okay, so very important topic. Okay, so be ready. Now the first colorless solution, I am going to add our NaOH solution, okay, which is also colorless, and I am going to add it. First, I have told you we are going to add it drop by drop, very slowly. So I am just taking this test tube, okay, you feel it, you also do it with me, and we are just going to add into this colorless metallic salt solution, okay, slowly, okay, so that the solution like just falls from the sides of the test tube, okay, very slowly. And what is happening, okay, by slow addition, okay, after adding a certain amount of NaOH, we are getting a colorless solution. But now in that colorless solution, you can find out some insoluble solid mass, okay, and this insoluble solid mass is getting settled down, okay, like we are waiting for some time, and then it gets settled down at the bottom of the test tube. Now such insoluble solid mass which is formed after mixing the solutions is called as precipitate, okay. So now from now onwards, we are not going to call it as insoluble solid mass, we are just simply going to call it as precipitate, okay, and you have to remember this, okay. It may be asked in your exam, means the question may come like this, okay, what is a precipitate? So you have to simply write this thing, very simple, what is actually happening, you have to write it. Now this insoluble solid mass which we are calling as precipitate, it is white in color, so I didn't colored it, okay, it's white, and this is a colorless solution. But now the real magic is happening now, okay, not now, but we are going to see the magic now. What is happening when we are adding, okay, in this solution excess of NaOH, okay. Now what does this mean, excess of NaOH? Which means now first of all we were adding very slowly, right? Now we are adding like somewhat in a fast pace, okay, and we are adding large amount of NaOH now, okay, not small amount, large amount of NaOH. And what is happening, you could see that this white precipitate, okay, it's slightly getting, you would be able to see that the amount of white precipitate which was there earlier, now it has slightly reduced, very slightly, okay. This means that this white precipitate is vanished, okay, slight amount of it is vanished. This means that the slight amount of it is dissolved in the solution, right, in this solution after adding excess of NaOH, large amount of NaOH. This means that we can say that this white precipitate, okay, is slightly soluble in excess of NaOH, right, slightly soluble, okay, or you can say sparingly soluble, okay, you can use slightly word or sparingly word, okay. Now what you have to remember is, in this process when we are adding NaOH solution into a colorless metallic salt solution, and if we are getting a colorless solution with precipitate which is white in color, okay, and this white precipitate, okay, it is sparingly soluble, or it is getting slightly solubilized when we are adding excess of NaOH. So such white precipitate, you have to remember it very clearly, such white precipitate is of calcium hydroxide, okay. Very simple. Out of this 6 metallic salt solution, I have told you we are having calcium salt, zinc salt, lead salt, iron salt, 2 salts are there, and 1 is copper salt. So out of this 6 salts, okay, we are going to see each case like this, and the precipitate which is formed after addition of NaOH, okay, drop by drop, and what happens to that precipitate when we add the NaOH in excess, this you have to remember. And what is that precipitate, you have to remember, which is that precipitate, you have to remember. Now in this case, this precipitate is calcium hydroxide, which is formed, okay, by addition of NaOH drop by drop in the colorless metallic salt solution, okay, and this white precipitate or this precipitate also is slightly soluble in excess of NaOH, okay. So such white precipitate which is formed is calcium hydroxide. Very clear. Now from this we are going to figure out that which metal ion is present in our metallic salt solution. How? Yes, see here. In this calcium hydroxide, we know that calcium 2 plus ion is there, right? And 2 OH minus ions are there. And then they are combining to form this calcium hydroxide, correct? So we know that these 2 OH ions would come from NaOH solution, right? This NaOH solution, okay, we know NaOH is a strong alkali, it gets dissociated, okay, and it gets dissociated into Na plus and OH minus ions. So this 2 OH minus ions would be coming from this NaOH solution. But now, from where this calcium 2 plus ion is coming? This calcium 2 plus ion must be coming from this solution. Exactly. Yes, we figured it out. So this means that we know that this is a metallic salt solution. And which metallic salt solution? That particular metallic salt solution which is soluble. Okay, means which metallic salt? The metallic salt which is soluble in water. Okay, such metallic salts solution is there. Okay, now we have already studied all about it. That's where you would now get help from, because now we have to write the name of the salt for writing the chemical reaction, what is actually happening, right? And how you would figure out the name of the salt, or how would you figure out that which salt it is? Okay, by just remembering the rules of solubility. Okay, now first of all, let's make it simple. We know that calcium 2 plus ion is in this metallic salt solution, right? We reached our goal. Very happy. Now let's try to figure out which metallic salt is actually there. Okay, and which metallic salt's solution it is. Okay, which can be the metallic salt? Now we have studied, we were talking about metallic salts, okay, which should be soluble, because those metallic salt only would form solution, right? We have already studied this thing. If the metallic salt is insoluble, it won't form a solution, correct? So we are now talking about such calcium salt which is, okay, having calcium 2 plus ion and which is also soluble in water. Okay, so now let's try to recollect the rules which we have studied for the solubility of salts. First one was all salts of sodium, potassium and ammonium are soluble. Now you should be handy with that chart, because I have told you that's important. If you haven't noted it down, just pause it here, go back, note that all the points, and then keep that page with you handy, because now we are going to talk about it frequently. Okay, so first rule I have told you, there doesn't come any point of calcium there, right? Sodium, ammonium and potassium salts are soluble. No help. We got no help to determine or to take any salt, okay, which is calcium salt having calcium 2 plus ion and which is soluble. Let's move on to the second rule. All nitrates and nitrites are soluble, right? So this means that calcium nitrate would be soluble, right? So I am writing here calcium nitrate, and before writing the salt, just check it once that this calcium salt, in this calcium salt, calcium 2 plus ion is there or not. So you can make out clearly. See, nitrate ion, NO3 ion, okay, it has a minus charge. Here there are 2 nitrate ions, right? Calcium nitrate. So this means that 2 minus charges are there. So for balancing it, calcium should have 2 plus charges. So yes, it is having calcium 2 plus ion as well, right? So this is how we could figure out a salt. And this part is important actually, because if in exams, if they ask you on your own to write the reaction, okay, they would, if they give you that, suppose we are adding a colorless NaOH solution or NaOH solution in a colorless metallic salt solution, and you are getting a white precipitate which is sparingly soluble after adding excess of NaOH, then write the chemical reaction. If they ask you such question, okay, then you need to figure out which salt you have to take, and that's where the solubility of salt part would help you, okay, and the previous concepts which we have understood very clearly, that would help you. Now just we have to write the chemical reaction of what has actually taken place, and this chemical reaction only you have to just focus on, okay, this chemical reaction and whatever things are happening here you have to focus on. That's why I have told you to take a big paper. So we have taken, now we are done with the reactants, now we are done with the product as well, now we are at the end of this, right? See, now what is happening, the next product, one product is this white precipitate, okay, and we denote it with this downward arrow, okay, in front of this substance, okay, we are showing a downward arrow indicating that this is our precipitate, okay. Downward arrow, it's very simple to remember, precipitate, insoluble solid mass settles down, okay, so downward arrow. Now the other product would be, see, try to figure it out on your own. It's very simple, logical. See, calcium ions and OH minus ions. These two are getting involved in the formation of calcium hydroxide. What is remaining? Sodium ions and NO3 minus ions, right? Nitrate ions. So it would form sodium nitrate. Very simple. Now just you have to balance this reaction. So it's also very simple. I'm going to tell you a trick to balance such reactions, okay, which we are going to see further. Okay, we are going to see such 5 more reactions for this 5 metallic salt solution. So how to balance it? See, simply, you know, there is one calcium atom, 2 OH minus ions. See, one calcium atom, but one OH minus ion is there here, right? NO3 minus ion, Na plus ion, one OH minus ion. Make it 2. Very simple here. I have made it 2. Now, see, 2 Na plus ion, 2 NO3 minus ion, 2 nitrate ions, right? So it would form 2 sodium nitrates, right? 2 sodium ions and 2 nitrate ions. Okay, sodium nitrate and then 2 sodium nitrates. So I will have to just write here 2 sodium nitrate in the product. Very simple. Now you can just figure out, see, this sodium nitrate, okay, it is a sodium salt. First rule, all salts of sodium, potassium, ammonium are soluble. So it is also soluble. And since it is soluble, that's why we cannot figure it out. That's why it is getting like disguised in this colorless solution. Okay, so in this colorless solution, this sodium nitrate is there. Okay, and we can see this white precipitate calcium hydroxide. Okay, because it is insoluble. That's why we call it as precipitate. Very simple. So this was our first reaction. Okay, okay friends, now it's time to see it's time to take the second colorless metallic salt solution. Okay, the first one we identified, in this first one calcium 2 plus ion is present. Okay, and we also saw that how NaOH, okay, reacted with the calcium salts, okay, having Ca2 plus ions and which are soluble, right? So moving ahead to the second one, now I am taking this second metallic salt solution. Now I am adding it into it NaOH. Okay, now we know the process. Now we are familiar with the process. So I am adding the NaOH drop by drop very slowly, and what I am getting a colorless solution. Okay, just like the first case, but in this colorless solution again I am getting a precipitate, and this precipitate again it is of white colored, but the twist in the story, here the precipitate is gel like. Okay, so you have to remember this thing. Now when I am adding excess of NaOH, which means now my patience limit is now off the way. Now I am not in the mood of adding it slowly. Now I have to add it in excess. Okay, but it's the second step. Jokes apart, it's the second step. We have to always add the NaOH in excess. After adding it slowly in the first step, we have to add it in excess in second step. Excess means in more amount. First we were adding it in smaller amounts very slowly. Now we are adding it in more amounts. What is happening when we are adding NaOH solution into this solution in more amounts? Magic happens. In first time the magic happened very slightly, but now here you would see complete magic. How? You would get a colorless solution. This white precipitate is gayab, vanished. Okay. Now where did this white precipitate go then? This means that this white precipitate is like it is getting dissolved. Okay, it got dissolved after adding excess of NaOH. Correct? Now, if it got dissolved after adding excess of NaOH, this means that this white precipitate is soluble in excess of NaOH, right? So I can write it here: soluble precipitate. Okay, this white precipitate is soluble in excess of NaOH. Okay, I'm not writing it again. So now let's see the reaction. But before that, again the same thing. We should remember, right, that if this is happening, if NaOH solution is getting added into this colorless metallic salt solution and we are getting a colorless solution but having a white precipitate gel like. Okay, first case was also white precipitate, but here the white precipitate is gel like, but here the white precipitate is also completely soluble or soluble in excess of NaOH, and such white precipitate, okay, gel like white precipitate is of zinc hydroxide. Now from this we can clearly make out which ion is present in this metallic salt solution. We know the process. See here, zinc hydroxide, it has Zn2 plus ion, OH minus ions, they are combining forming zinc hydroxide. This Zn2 plus ion Now we know this OH minus ions is coming from this NaOH, but the Zn2 plus ion must come from this metallic salt solution. This means that our metallic salt solution has Zn2 plus ions, right? Very simple. Yes, we figured it out. Okay, now it's time to write the reaction. So what we have to remember is we have to take a metallic salt, okay, which is having a Zn2 plus ion in it, and it is soluble, right? Then only it would form a solution. Okay, and here we are dealing with the metallic salt solution. So quickly let's figure it out. So first rule, no use for zinc as well. It belongs to sodium, potassium and ammonium. Second is zinc nitrate, zinc nitrites. Yes, they are soluble because all nitrates and nitrites are soluble. But let's move ahead. Let's take some another example. Okay, then moving to the third rule, chlorides, all chlorides, bromides, iodides are soluble, right? But exception was Hg2Cl2, mercury, the chloride of mercury, chloride of silver, AgCl, and chloride of lead, PbCl2. But here doesn't come the exception of zinc chloride, right? This means that zinc chloride is soluble, correct? So we have taken some another salt, okay, for a change. Let's not do it nitrate, let's take a chloride then. And we have tested it as well. We have just gone through it, gone through the rules and just confirmed that yes, zinc chloride is soluble. Okay, so yes, I have taken this zinc chloride, and I also know that in zinc chloride, zinc is as Zn2 plus ion. Okay, since chlorine, okay, there are two chlorine, so two chloride ions, 2 minus charge, right? So zinc should have 2 plus charge in order to balance it. So now I am having this reactants and the product. Okay, now it's time to write the last product, okay, the second product, which is hidden in this colorless solution, right? And you know the trick, very simple. See, zinc and hydroxide ions are involved in the zinc hydroxide formation. What is remaining? Sodium and chloride ions. It would form sodium chloride. We know this, that sodium chloride, sodium salt, soluble in water, right? So therefore this sodium chloride, okay, is present in this colorless solution, and it is soluble, and as well as it is colorless as well, right? We know representative element salts are colorless, so it is a representative element, colorless salt, soluble salt. It is getting hidden, it is hiding itself in this colorless solution. Okay, very simple. Now when we are adding excess of NaOH, okay, that reaction we have to also study what is actually happening to this zinc hydroxide precipitate. Okay, but before moving ahead, let's just balance it. Same trick I would use. Zinc, yes, Zn is there here, but 2 hydroxide ions I need 2 hydroxide ions, so I have just took here 2 OH, right? Then what is happening? 2 sodium, 2 chloride, 2 sodium chlorides, balanced. Okay, now this zinc hydroxide precipitate is soluble in this excess of NaOH. This means that it is reacting with excess of NaOH, correct? So now what I would do is, okay, forget it here, I would write it here. This zinc hydroxide precipitate, okay, it is reacting with excess of NaOH. I would write excess above, okay. And what is actually happening in this reaction? A salt is getting formed, and that salt is colorless and soluble. See, that's why that salt is colorless, right? So the solution won't be any colored, and I have told you we are getting a colorless solution after adding excess of NaOH, okay, in this solution which was having a white precipitate, okay, gel like precipitate. So the salt which is getting formed, it is colorless salt, and that salt is also soluble salt, okay. So that's why it is also getting soluble, okay. So we are not able to figure it out where the salt went. It is in the solution, hidden, right? So the salt which is formed here is, let's not make any what I can say, the suspense about the salt. See, sodium, okay, first water is getting formed, okay, we know that salt and water is going to be formed. So water I have written here, and what you have to remember is how salt is getting formed. See, sodium and zinc, so it would form sodium zincate, okay, Na2ZnO2. This is the formula of sodium zincate. Okay, and I have already told you this salt is colorless as well as soluble. That's why, since it is soluble, it is getting solubilized in this solution, right? It is getting solubilized. We cannot able to figure it out, and it is colorless as well. So the solution's color is colorless. Very simple. Now you have to balance this reaction as well. Okay, we have just now seen this reaction. We have balanced it. So the another reaction here, It's very simple to balance. You have to just now try it with trial and hit method. Okay, you have studied it in 9th. So this I have told you a simple trick, but here you have to use the same method. So I'm starting with here sodium, 2 sodium, so 2 sodium, zinc 1, zinc 1, okay, oxygen 2 and oxygen 1, 3 oxygens. So here I am having 2 oxygens and 2 oxygens, means 4 oxygens. So I have to make there 4. So it's simple. I would just add 2 here. So what would happen? See, 2 oxygens, 2 oxygens, 4 oxygens. Okay. Then moving ahead, 4 hydrogen, and here you can see here 2 hydrogen and here 2 hydrogen. So yes, it's balanced. Oxygen we have already balanced. Okay. So these 2 reactions, okay, are for the Zn2 plus salts. When this Zn2 plus salt solution, okay, we are treating it with NaOH. So far we have figured out 2 metal ions present in these 2 metallic salt solutions. Now moving to the third metallic salt solution, again the colorless one. We are going to finish first colorless. Now I think you are familiar with the process, entire process. So now we would just go along it through it very simply, okay, and quickly. So the third colorless solution I'm taking, I'm adding NaOH solution into it, drop by drop, slowly, and what I'm getting, I'm again getting a colorless solution, but here again I'm getting a colorless solution, and again I'm here getting a precipitate, which is again of white color, but this white color precipitate is chalky in nature, okay, chalk like. So this is how we could distinguish between the zinc hydroxide and the upcoming hydroxide. I am not going to tell you, let it be the suspense, right? What is happening again? The second step, we are going to add excess of NaOH. So what is happening? Now this colorless solution having this white chalky PPT, it becomes simply colorless. Okay, this white chalky PPT disappears, gayab. So this means that this PPT is soluble in excess of NaOH. Okay. Now let's see the reactions. So the same way we are going to figure it out, but before that we need to just remember which PPT is this. So throughout this process, okay, if we are adding NaOH solution into this colorless metallic salt solution, okay, and we are getting a colorless solution along with a white chalky PPT which is soluble in excess of NaOH, then such precipitate is lead hydroxide. Okay. So now we know that this means here lead hydroxide, lead is in Pb2 plus ion. So this means this metallic salt solution has Pb2 plus ion. Very simple. Now again we know the hydroxide is coming from NaOH solution. Now we have to figure it out that which lead salt we can take which is having Pb2 plus ion in it, and it is soluble in water as well in order to form the metallic salt solution, lead salt solution. So let's take nitrate, okay, because we know all nitrates and nitrites are soluble. So let's not make it more complicated. Let's simply take lead nitrate, PbNO3 twice. Okay. Now a disclaimer, see, lead chloride, this third rule, lead chloride is insoluble, right? All chlorides, bromides, iodides are soluble, but lead chloride is insoluble in cold water, but it is hot water, it is soluble. Now here we are not talking about the hot and cold thing, so let's just forget about lead chloride here. Okay, no need to get into that argument whether we are taking hot water or cold water in order to make the solution. Okay, lastly it would get cold only, so no need to take risk with that lead chloride salt. Okay, let's just skip that lead chloride salt. Then what is happening next are sulfates, but since all sulfates are soluble, but exception again is there, and that in that exception calcium sulfate, lead sulfate and barium sulfate, they are insoluble. Okay, I know that, I hope that you are seeing that chart with you, because I am not having that chart but I am remembering that chart. Okay, so you also remember that chart. Till then you can just keep that chart handy with you. Okay, the solubility of salts. So we cannot take, the conclusion is we cannot take lead sulfate as well, right? So that's why I have to taken the lead nitrate itself, the second rule I have followed, and the last one was that about the carbonate sulfides, and they are all insoluble. Okay, but except of that of ammonium, sodium and potassium, so that also we cannot take for lead salts. So lead nitrate is the soluble salt. Okay, we figured it out, which is having Pb2 plus ion. We took that salt and written it in the reaction as a reactant. Here this second reactant first product we got. And in this colorless solution, now you know there must be some salt, okay, which is present in this colorless solution. Now we have to figure it out what it is. Very simple. Lead, OH minus ions, they are forming lead hydroxide. What is remaining? Sodium and nitrate. Simply it is sodium nitrate salt, okay, and we know sodium salts soluble in nature, sodium salts colorless because of it is representative element salt, okay. So this colorless soluble salt, okay, soluble, that's why we cannot able to figure it out in this colorless solution, right? And since it is having no color, that's why the solution is becoming colorless, okay. So this is present simply in colorless solution. You have to just remember in this way. Very simple. Now balance it. See, lead hydroxide, okay, 2 OH minus ions, simply 2 OH, okay. So 1 lead, 2 OH minus ions are done. Then 2 sodium ions, 2 nitrate ions, 2 sodium nitrate, balanced. Now moving ahead, we have to also learn the reaction when we are adding excess of NaOH, because that is important. Why? Because our PPT is getting soluble, right? The magic is happening. So it's very simple, same like that of the zinc hydroxide, okay. What is happening for this part? Again, we know that since our PPT is soluble in excess of NaOH, this means our PPT is reacting with NaOH. Same way, I have taken our PPT, lead hydroxide, I have taken NaOH into it, it is reacting, it is forming the same type of salt like that of the zinc, okay. It is forming sodium plumbite, Na2PbO2, okay. It is sodium plumbite, okay, not plumbate, it is plumbite, okay. Just the slight change, it was zincate in case of zinc, it is plumbite in case of lead, okay. Plumbum, right, from where we know Pb is plumbum. So, and water is going to be formed. Now this sodium salt, again colorless, and again we know that it is soluble as well because it is sodium salt. That's why it is forming this colorless solution, okay. And next is water. So water is also, we know, colorless, right? Now we have to balance it. Simply 2 sodium, 1 lead, 1 lead, oxygen 2, 1, 3, okay. So here 2 oxygens, 2 oxygen, 4 oxygen. So I am making here 2, then 2 oxygen, 2 oxygen, 4 oxygen. So here also 4 oxygen, there also 4 oxygen. Oxygen balance, and remaining 4 hydrogen. See, okay, after oxygen I have jumped to the hydrogen, 4 hydrogen. So here you can see 2 hydrogens, okay, and then 2 hydrogens. So 4 hydrogens already balanced. So these 2 reactions, okay, you need to emphasize on, and you would able to write these 2 reactions when you would know this entire story, this simple story, what is happening, okay. Very simple. Now comes the colored reactions, right? There would be some color in it, okay. So this enjoying part I have kept it in the second part, okay. So I am taking this first colored solution which is having pale green color, okay. So now this solution having this pale green color, and I am having, we know, NaOH solution. What we are going to do? Add it drop by drop. What I am going to get? I am going to get a colorless solution, but here I am going to get a PPT as well, okay. Now this PPT is of, okay, so this PPT is of dirty green color. So dirty green color means it is green, but you can see some blackish shade in it, okay. That's why I have shown this blackish shade, okay. So you would see this dirty green PPT, okay. Now you have to remember the PPT's color as well, okay. So which PPT we are getting, you have to remember that PPT's name as well, dirty green PPT, along with this colorless solution. Now what is happening? When we are adding excess of NaOH into it, no magic at all, okay. So we are now just we can take a sigh, because one more reaction which we would have to study, that has reduced, right? So here the precipitate, this dirty green precipitate, is insoluble in excess of NaOH, okay. So very simple. Now you have to remember, when we are adding this NaOH solution into this green, pale green color, okay, pale green colored metallic salt solution, okay, then we are getting a colorless solution with dirty green PPT, which is insoluble in excess of NaOH, and such dirty green PPT is of ferrous hydroxide. Okay, now why I am calling it as ferrous? Because it is having ferrous ion here. Fe2 plus ion and 2 OH minus ions would form this FeOH twice, which is called as ferrous hydroxide, right? Now we are now clear. This OH minus ion is coming from this NaOH. Fe2 plus ion is coming from this metallic salt solution. This means that our metallic salt solution is having Fe2 plus ions. Okay, now we have to take a Fe2 plus ion, a salt having Fe2 plus ion, which is also soluble, right? So now we are just like nitrate. We know we can take ferrous nitrate as well. We can take ferrous chloride, ferrous bromide, ferrous iodide, because iron salts are not in the exception. We can also take ferrous sulfate as well, right? Because it is also not in the exception. So let's take ferrous sulfate. Let's try new ones. Okay, I took ferrous sulfate, sodium hydroxide. They're giving us this dirty green PPT, and along with it, we know another salt is also going to be formed. Okay, which would be colorless and which would be soluble, because that's why it is present in this colorless solution. Okay, this colorless part. So which would be that salt? See, Fe and OH, they are forming ferrous hydroxide. What is remaining? Sodium and SO4, right? Sulfate. So it would form sodium sulfate, Na2SO4, right? Now see here, 2 OH minus ions are required. So balance it simply. I am writing here 2 in front of NaOH. Okay, 2 OH minus ions, 1 Fe. So see, 2 OH minus ions, 1 Fe. This is balanced now. Now what is remaining? Na2SO4. See, Na2SO4 balanced. Simple. Okay, this Na2SO4 is present in this colorless solution. So one by one we have seen the action of NaOH on calcium salt, zinc salts, lead salts, and now we have seen just now the action on Fe2 plus salts like ferrous salts. Now it's turn to see the action on the next salt, but wait a minute, we will discover it. Simply, you know, the same process, adding NaOH, right, drop by drop into this yellow colored metallic salt solution. Now it's this yellow colored solution's turn, okay, to get discovered. So we are adding it into this yellow colored metallic salt solution, NaOH, drop by drop. What we are getting? We are getting a colorless solution with a precipitate, right? Now this precipitate is having which color? You can guess. Yes, if you would not go wrong, but it is actually having some darker shade of yellow. Okay, it is not that yellowish. Okay, it is reddish brown precipitate. Okay, very simple, reddish brown, and you have to remember this color as well. Now what is happening? After adding excess of NaOH into it, this precipitate remains as it is. Okay, so this means that this precipitate is insoluble in excess of NaOH. Okay, very simple. Now moving ahead to the chemical reaction which we have to write. Now in this case, after adding NaOH solution into this yellow colored metallic salt solution, if we are getting this reddish brown precipitate, okay, which is insoluble in excess of NaOH, then this reddish brown precipitate is of ferric hydroxide. Why I am calling it as ferric? Okay, ferric hydroxide, sorry, FeOH thrice. Okay, why I am calling it as ferric? Because this ferric hydroxide is made up of Fe3 plus ions. Okay, and these ions are called as ferric ions. Okay, Fe3 plus ions and 3 OH minus ions. So now let's write the reaction. We know OH minus ions are coming from NaOH, and since this Fe3 plus ions are present in this ferric hydroxide, this means this metallic salt solution is having Fe3 plus ions, right? Now we have to just figure out which Fe3 plus salt, a ferric salt, which means iron salt, okay, having Fe3 plus ion and which is soluble in water, right? So let's take the example of chloride. Okay, let's not now waste much time in these things. Okay, now we know all the rules and all those things, so you could figure it out. So I am taking FeCl3. Okay, you can check with the chart. All chlorides, bromides, iodides are soluble, and exceptions, there are 3 salts. In this, iron salt is not included. So FeCl3 is soluble. Now we have just figured out one product, right? FeOH thrice, ferrous hydroxide, FeOH thrice. What is remaining then? NaCl. Simple. And this NaCl is present in this colorless solution, since it is itself colorless and it is soluble as well. Okay. Now, what we have to do is, we have to just balance it. So, 1 Fe, 1 Fe, 3 hydroxide ions are coming from this, 3 NaOH. Okay, what is remaining? 3 Na, 3 Cl, becoming 3 NaCl. That's it. Okay, now moving ahead to the last colored salt solution, right? Colored metallic salt solution. Now you would say, sir, it is of Cu2 plus, right? Cu2 plus ions are present in this. But now, yes, we have to see the same like that we have done for all the other metallic salt solutions. We are going to add NaOH solution drop by drop into this solution, and what we are getting is a colorless solution. Okay, from blue color it is getting colorless, and we are also observing a PPT. Okay, now this PPT, okay, this is colorless solution. Now this PPT is of pale blue color. Okay, pale blue. Okay, very easy to remember. See, blue colored solution is giving pale blue color. Okay, now after adding excess of NaOH, what is happening? The PPT remains as it is, which means that PPT is insoluble. So that we only now need to study one reaction, which is of this, because here since PPT is insoluble, there is no reaction taking place. Okay, now which one reaction we are talking about? We all know how to now write that reaction, but before that we should know that what actually this pale blue PPT is. So this pale blue PPT is of copper hydroxide. Okay, CuOH twice. Now again the same story, when we are adding NaOH solution into this blue colored metallic salt solution, and we are getting a colorless solution in which we are finding a pale blue PPT, which is in turn insoluble in excess of NaOH. Okay, so that such pale blue PPT is of copper hydroxide. You have to remember this thing. That's it. Now you could easily figure out which metallic ion is present in this metallic salt solution. Okay, how? We know in this copper hydroxide, copper 2 plus ions are there and OH minus ions are there. 2 OH minus ions are there, right? So CuOH twice. Now we know OH minus ions are coming from NaOH. Now this Cu2 plus ions are coming from this metallic salt solution. This means that this metallic salt solution is having Cu2 plus ion. Same like that, all story remains the same. Okay, now we have to figure out Cu2 plus, a salt having Cu2 plus ion and which is also soluble. So simply let's take copper sulfate. Okay, sulfates, all sulfates are soluble. Exceptions are lead sulfate, barium sulfate, and one more is I guess lead sulfate, it's barium sulfate and calcium sulfate, right? You can see the chart, but not the copper sulfate, right? So copper sulfate we can take it, CuSO4. Okay, now we have one product. This is the precipitate. Okay, pale blue colored precipitate, copper hydroxide, and now remaining we can write the reaction. See, copper hydroxide, CuOH twice. What is remaining? Sodium and SO4. Okay, sodium and sulfate, so forming sodium sulfate, Na2SO4. See here, now copper 1, okay, 2 hydroxide ions are required, so I am writing here 2 NaOH. Then see, Na2SO4, it is getting balanced, Na2SO4 simply, and this Na2SO4 is present in this colorless solution. We all know this is a soluble salt since it is a salt of sodium, and it is also a colorless salt, so it is present in this colorless solution. And as I have told you that no need to now worry about the second reaction, because since PPT is insoluble, so there is no reaction taking place here. Okay, simply now we are going to see a special case. Okay, now we are done with all these 6 metallic salt solutions. Now a special case which is of ammonium salts. Okay, now already we have studied this in the properties of bases in chapter number 2. The same reaction we are going to study again. What is happening? The action of NaOH when we are adding NaOH solution, okay, in the solution of ammonium salts. Let's take, now we know already ammonium salts means it is having ammonium ion, NH4 plus ion, okay, and one negative ion. So I am taking here example ammonium chloride, very simple example, ammonium NH4 plus Cl minus, okay, ammonium chloride salt. This is an ammonium salt. and I'm adding it into the water. Okay, we know all ammonium salts are soluble, so it is also soluble. So this ammonium chloride solution, and there is sodium hydroxide solution. Okay, now what is happening is, we already know when we are adding these alkalis into this ammonium salt, or when these alkalis are reacting with these ammonium salts and we are heating it, okay, what is happening? We are getting a salt plus water and ammonia gas is liberated. Okay, so same way, so now we would get a salt. Let's write first water and ammonia gas, and then let's figure out which salt would be formed. Okay, now liberation of a particular gas is shown by an upward arrow because it is going out, उड़ जाता है वो. Okay, so now see what is remaining. See, oxygen, hydrogen and this NH4, oxygen, hydrogen involved in this water formation, NH4 is involved in this ammonia gas release. So what is remaining? Sodium and chlorine, right? So make a salt, sodium chloride. Now this ammonia gas, sometimes they ask you in examinations that give an observation. Just also we have seen in the previous chapter, okay, give an observation or state one observation when you add alkali, okay, and you heat that alkali along with ammonium salts solution. So what is happening? See, ammonia gas is released. This you would observe. And how you would observe? Ammonia gas has a pungent smell, okay. So when you would take your nose close to the test tube where this reaction is taking place, you would feel this pungent smell. Now what is pungent smell, sir? Pungent smell is a sharp smell, okay, or strong smell. So you could not bear that smell, okay. It's very difficult to bear that smell. So such smell gas, when it is coming out, you can just figure it out that this is ammonia gas. Okay, so you can write the observation as in the answer that a pungent smell gas is released. Okay, very simple. So with this we have reached the end of this video, and I hope you would have understood all the concepts which we have learned in this video, and you would have enjoyed learning with me as well. But please do let me know in the comment section, and you also know LearnoHub matlab free hai par best hai. So we will meet in the next video with the remaining concepts of this chapter. Till then, stay tuned. Bye bye and have a great day.